This is Statistical and Geospatial Insights YouTube channel. We are meeting again in lesson number 10, which is about type 1 and 2 errors in hypothesis. By the end of this lesson, you'll be able to distinguish between type 1 and 2 errors in hypothesis. A type 1 error is called a false positive, where a true null hypothesis is incorrectly rejected, meaning an effect is detected when there is none. For example, if the null hypothesis is saying that there is no sickness or there is no disease, while the alternative is saying there is sickness. So this true null hypothesis was rejected. And then we accept the alternative hypothesis, which is saying that there is sickness, but that person is not sick. And another example is that a patient went to hospital and the doctor recommended that he should do a blood test for malaria. When the result came out, so the result came out positive that this guy, that person had malaria while he didn't have malaria. Whereas in type 2 error, this one is known as a false negative, where a false null hypothesis is incorrectly not rejected, meaning a real effect is missed. For example, in the case of that person who went to hospital, when his blood was diagnosed for malaria, though he had malaria, but the result came negative that he didn't have malaria. So this one is known as type 2 error, which is actually failed to reject a false null hypothesis. So rejecting a null hypothesis that is actually true is called type 1 error, which is false positive. For example, a medical test indicates a patient has a disease, but they are actually healthy. A fire alarm is going off when there is no fire. That is, the fire alarm will just make signals when there is no fire. The probability of type 1 error is denoted by the alpha letter. Type 2 error, false negative, failing to reject a null hypothesis that is false. A medical test fails to detect a disease in a patient who is actually sick. A fire alarm fails to make signal when there is a fire. The probability of type 2 error is denoted by vita, the Greek letter vita. Now here, when you look at this table, to read this table, first of all, you have to be very careful. You have your null hypothesis here, whether it is rejected or it is not rejected, the decision for the null hypothesis. So when you have a true null hypothesis, when it is rejected, then we say this one is type 1 error, false positive, and the probability is denoted by alpha. Whereas the correct decision, which is actually the true negative, the probability is denoted by 1 minus alpha. When you add the two probability, you'll get 1. This is a rule in probability. So for type 2 error, type 2 error is a false negative when we fail to not to reject a false null hypothesis, and the probability for this error is called vita. Whereas the correct decision, which is the true positive, actually, it is a true positive because that guy had malaria, but it was not actually diagnosed. So this probability is 1 minus beta. So when you add 1 minus beta plus beta, you'll get a probability of 1. The severity of each error depends on the context and situation. For instance, a false negative in a disease is very dangerous because that person was actually having the disease and he was declared to be healthy. So he will miss taking the medicine. This may lead to his death. However, in type 1 error, in the case of disease which is the false positive, a person who was not sick was declared to be, a person who was not sick was declared to be sick. He will take the medicine, but the medication will not kill him. Therefore, type 2 error in the context of disease is more severe than type 1 error. In conclusion, formulating the right hypothesis is really very important. We need to have a clear, testable focus for research. It gives a roadmap for data collection and analysis. It prevents blind research. Then a strong hypothesis can give direction to the research. It can help researchers to predict relationships between variables. So thank you to attend this lecture. lesson. Meet in the next one.